continuing with various computation examples that analysis editor gives us the support for. In this particular module, we shall take the examples of the packet loss in client-server communication paradigm when different pairs are communicating with each other on, let's say, shared LAN or a WAN link. Then we are going to determine the total number of transport packets which get sent or received in a network. And finally, we are going to look at the modules in a network which are experiencing the largest round-trip times. First, the packet loss per client-server pair. Let's look at the scenario. Here, you see that there are 3 clients and 3 servers. There are specific respective notations given to these, such that client 0 talks to server 0, client 1 talks to server 1, and client 2 talks to server 2. Each client sends the datagrams to its respective server. If we really want to determine the packet loss at the per client level, we actually have to ensure that the sent and received packets belong to this particular session between client and server. For that, we need to use the I variable. If we look at the value, you see that the clients and the server packets are over a single communication session. And if we take a difference of these, this will give us the loss in terms of packets. Here, the counter I tallies the clients to their respective servers. If we don't use this, we are going to have a kind of Cartesian product here, which is not desired, because here we just have 3 sessions. In the other case, we'll have more than 3 sessions. If you want to determine the total number of transport packets in a network, what we are interested in is any transport packet, including both TCP and UDP. So here, what we are going to do is, we are going to, in the value section, determine a sum of these. The sum of the UDP packets which are counted and the TCP packets which are counted. Here you see that depending upon the requirement, for a certain host, all the applications which are running on that particular host, if they're generating transport layer packets either on UDP or on TCP, then the traffic from that particular host must be taken into account. For example, if a certain host is running FTP, FTP uses TCP. Similarly, if there's another application running on the same host, such as TFTP, the Trivial File Transfer Protocol, it uses UDP. But since both of these, FTP and TFTP, belong to the same host, therefore we need a mechanism such as the one shown to you here, that the host is actually declared to be a certain host, and only then its packets for TCP and UDP are counted. Moving on with the examples, if we want to determine the largest round trip time, and we want to measure and identify the module which is giving us the largest round trip time, let's take a look at this scenario to understand that. Let's assume that we have a network with various modules which are measuring the round trip times using ping. If we really want to count the modules with the largest round trip times, we actually have to understand that the round trip time is actually already averaged and stored when we perform ping, because ping does it for multiple packets. We actually need to do this in steps. How are we going to do it? First of all, we are going to determine the average of the round trip time which is stored in vector. Then we are going to determine the relative average, that is, the average for all the nodes or all the modules within the network. And in the third step, we are going to count the relative average, and we are going to look at all those modules for which the round trip time average is exceeding twice the average of the whole network, and then we are going to give the count of these. So what we essentially get is, we get the modules, their numbers, the number of modules, which are generating the round trip time averages more than the global average of the overall network.